All right, so it's time to get cracking on this a little more. Just working on some other stuff in between. So the next big step, so I know that I'm going to be basically making, the foldy bendy method here. I'm going to probably break this into multiple boxes and stuff. So I'm still working on that, but it's going to be similar to that SAC directional sign that you saw that I made the videos about. So it's going to be same construction, but these boxes here are going to be, I'm seeing that these are going to be some 063 boxes. And I need to figure out how big to make that 063 box. So you're like, well, yeah, it's 8.5 by 3 foot. No, because that's the face. That'll be the overall size of the acrylic face. I need to work backwards, but I also need to leave tolerances for the heat expansion of the acrylic and for the most part, the aluminum too. But I'm going to show you why the acrylic and things like the polymerics, the thermoplastics, are super active compared to metals, which they grow a lot too. Steel grows quite a bit when there's a lot of steel. So you need to kind of take into account the expansion and all that. So I'm going to go ahead and get this dialed in as well. So we got, this kind of stuff. I kind of have to do these preliminary things. So we already talked about that. And then I need to dial in these, and then that will allow me to start getting cracking because I need to work backwards from the size of this box to the size of how it fits into here. And then that gives me, and the same thing here, once I get these dialed in, then I can start to make this, but I can't make this until I know, working backwards from the actual acrylic. So let's go ahead and make a work page. Because again, I work from, this is, I know I kind of did this here, but this is sort of my copy of record, my source of truth. So this is what I leave all of this original. So that way I can go back to it and see exactly what we thought we were doing here. And then any changes I make, I just take those forward. So I'm going to call this work page. I'm going to hit the WP on the exporter. And then we are working with these faces here. So I'm going to grab that. I'm just going to load it up into my rectangular because we got to kind of clean it up. And then I'm just going to hit X, and that's going to give me 36. And there we go. So this is going to be the face. Since it's polymeric, I'm going to go ahead and hit the light blue. I like that for acrylics, things like that. If I'm using the like the wireframe for building like this. And then also, I know that this is also for like inlines and things, but I know the difference for the most part right now. So we're going to go ahead and make a side view because you always build, you can design from the front, but you need the side to build. You need that extra dimension. So I need to know how deep I'm making and how wide and flanges and things like that. So this is going to be the acrylic. And then I'm going to make there's Y. And then I'm going to refer to this down here on my Mr. Good bar. I'm going to refer to this Plex. So I'm going to click on that and it brings up it's a JPEG, but this is a scan I made of thicknesses and tolerances for the acrylic sheet, as it says. So as we know, the rest of the world is millimeters, as it should be. We're over here always playing in inches, and sign people are always shooting themselves in the foot because they say 1/2 inch acrylic, and then they wonder why things don't fit. So 3/4 inch acrylic is 18 millimeters, but it's actually 0.7. I round up, it's 0.71. If you really, really need to hit the target, you need to go back and ask Jose which piece he would use when you send him route files. Then you need to go put some calipers on it, and you need to dial in exactly, because the tolerances can be anywhere from 0.749 all the way down to 0.61. So 3/4 is not 3/4 at 0.619. So sometimes if it's really critical and you need to have that depth set, then I would go back, find a piece that fits, say, hey, would you use this for this job? And Jose be like, yeah, it's the one I'd use. Then I would like write on it and say, this is mine. I'm going to throw calipers, and then I need to know. So I'm using this because I need that thickness, and I need to know that is, because that could be 0.73 and maybe, or even 0.74. It could be very close to 3/4, and maybe the 18 millimeters is off. So, but you say, hey, I need to have that. So I'll set it aside and say, hey, when I send you files, please use this because I've calipered it. And he'll just be like, you're weird. Go away. That's what he tells me anyway. So I'm going to do 0.71 for my X. There you go. So there's the thickness. And then I'm going to go ahead and do a flange. So on this for beef, I'm going to do an 1/8 inch flange. 1, 2. That's my nudge. So that's 1/8 inch there. And then I'm going to go ahead and just bring this down. So that way, so I have 3 right here. I have the overall thickness that's left because I'm going to have him route this, island fill down. So we'll have 1/8 inch against the table. We'll have an 1/8 inch lip. And then I'm going to go ahead and shrink this 1/8. Actually, we can do, 1/8 on both sides. Yep. So we're going to shrink that 1/8 on both sides. And then I'm going to go ahead and shrink this 1/8 on both sides. Okay. And then, so that's going to be, we'll save that. So that's the side profile. So we're going to have an 1/8 inch flange, nice and strong. And then I'm going to have that 1/8 inch there just to have that lip, that beef. So that's like working with an 1/8 inch piece of acrylic. And that's good. I mean, 1/8 inch is pretty strong when you're dealing with, only 3 feet by 8.5. Then an 1/8 inch is pretty strong there. So now I'm going to just go ahead and hit nugget 0625. And then I'm going to make my cabinet, right? And we can just make that line up there. Now, if this was going to be bleeding edge, like cramming this in, then I might just leave that there because I want a tight shoebox because we're obviously not going to be able to put fasteners here and here. Once you try to cram fasteners in there, there's really no, 90-degree bit, anything that's going to get in there. So we're going to rely on this 3/4 inch acrylic being clamped, shoeboxed in there by the perimeter aluminum frame. And again, since we're going to be making essentially 24 boxes, I'm going to try to make them as easy as possible, but we're going to have 24 boxes here and then however many boxes that is. I'm going to go ahead and keep it at a 1/16. Plus that keeps the shadow down. I understand it's not that much different than 09, but it just keeps the shadow down a little bit and it's just less material and it doesn't have to be super strong. So now I'm going to go ahead and make this the actual size. I know my nuggets are only 1 inch. But I'm going to go ahead and make those the full return depth, right? So that way we're kind of playing with what's actually there. And then I'm going to go ahead and just make that overall. However, what I just said, I think I want to scooch this. I'm going to go ahead and scooch this in 01 just to give it that little bit of breathing room. Now I do want it to essentially grab this 100%. But as you can see, we're gonna figure out the thermal expansion of this. We need to leave room for summertime. Plus, what you can actually do, rather than making it so tight that it doesn't work, you can actually take and adjust this and kind of bend it down a little bit. Once everything's made, you could either take your fist like an animal and kind of hit the back of your fist and bonk it, or you can take like a dead blow and sort of just put pressure and kind of bend that down a little bit. So that way, when you go to put this in, you do kind of need your back of your fist to kind of bonk it in tight and it's there. And that's what we want. So now that I have this, I can make my side profile. I'm going to hit bam, make that red as well. So that's my return on the side. So this essentially will be my box-ish. And then I'm going to go ahead and put 2 screws on the ends. And then I'm going to go ahead and just make sure that they're lined up with what's left of the plex. I'm going to center it in this, what's left here. And then I'm going to put that in the center, but I want 2. And I'd like to see them right about here, about like there and there. So let's see what 1, 2, 3, 1, 2, 3, 3 inches. That's 6 inches apart. That looks good. We're keeping away from the edge here. You get too close to the edge, cracking and things like that. Plus it looks nice. Once you get a few of these going, it'll be nice and staggered. So anyway, so I like that. Save, save, save. So let's go ahead and get the front view to match what we got here. So we're going to take this 36, and we're going to let's just put a inline 0.125 on that. Okay. So that's our flange and we'll keep it color coded. Okay. And then we can go ahead and do a 0.1 outline on that. Okay, that'll be red. And then we can do the 16th and that'll be red. Okay, so this is my proposed box, right? And then that is the proposed island fill. So that's the 1/8 inch flan and then this will be the full 0.71 all the way. That's first surface all the way down to the table. And then this will be second surface, 1/8 up from the table. All right, so now I need to make sure, now because nothing is static, it's static in this picture, but the second this hits the sunlight, this will want to grow, it'll want to shrink, and so will the aluminum, but the aluminum metals don't move nearly as much as plastics, thermoplastics, polymerics, whatever you want to call it. You got your polycarbonate, you got your acrylic, you got your PVC, which is Sintra. You've got basically Sintra, which is a Luca bond, same thing. You've got, what else? You got ABS, right? Black plastic, like black sewer pipe. That stuff moves a lot. ABS is very moving, thermo, whatever you want to call it, thermodynamic, whatever. So all of that is, you can figure this stuff out using the coefficient of thermal expansion. So we ran into trouble with this, and so years and years ago. So I went to school on it on my own, and I figured out that there's ways to calculate it. So up here, well, on your go time, it looks like a thermometer, right? You're going to click that, and it's going to pop open Shrinky Dink. Shrinky Dink is the macro that you use to figure out how much all of these different types of things, Corian, aluminum, steel, or other, if you want to go get the formula, and then you can figure it out for yourself, how much things are going to grow and how much you should leave for room for it to wiggle and move around. So that being said, it was ironic. The thing that actually got us in trouble is we tried to do a Corian sign, but we didn't leave enough room for it to shrink. Weirdly enough, you would think in the summer we would have the issue with the heat and expansion. Yes, we do get in trouble with that too. But if things get too cold, then it contracts so much that it will break in half. If you don't give it enough room and you don't allow it to shrink, it will pull itself apart. And that's what happened. We had some Corian literally rip itself apart because we had some record cold snaps, especially it was down in Palm Desert. And I checked the almanac of a couple of years after this had happened. The customer called and said, why is there a giant crack through the face of our sign? And it was Corian. And it was like, well, we have no idea. Why would it crack in the summer? You know what I mean? Like heat. Why would it crack from heat? No, I checked it out. I went into the Farmer's Almanac and I looked, and we had a record low of almost like 20 something degrees Fahrenheit. So well past freezing. And it had shrunk so much that it had shrunk past its aluminum cabinet it was attached to. It was skinning an aluminum cabinet. And so the aluminum cabinet only shrunk so much, but the Corian actually shrank almost a 1/2 inch. And so that 1/2 inch, it had to go somewhere, and it literally ripped itself apart, and it was cracked open. So anyway, we had to go, it was a lesson learned. So from that point out, we had to, I was like, we are always going to make sure that we are allowing for the thermal expansion. So if you want to find these, steel and aluminum are basically elements that you can find that from engineering websites and things like that. But all you got to do is go to the name brand of the manufacturer of what you're wondering things will expand and contract. Go find their technical PDF that has their physical properties and their all that, and it will have this formula, and it's called the coefficient of thermal expansion, and you would plug that in, and then you could figure out. But you do need the cut temperature and the final temperature, and you also need the overall size, how many molecules you have. Now, what it's doing at its heart is taking into account how many molecules. And so whoever cooked up Plaskolite knows the behavior of one molecule. And then they know that when you add so much heat, that molecule changes size to this order of magnitude here, which is, 4 to the -5. So 0.00000 whatever. And then when you add more and more molecules, well, they're going to expand. They're going to say, excuse me, and they push their neighbor, except the neighbor pushes the other neighbor, and then it's a chain reaction all the way down. That's why you get more movement when something's longer, because there's more molecules, and you'll get less movement on something that's shorter. So oftentimes on something like this, I barely take into account the up and down this way, because there's much less molecules to say, excuse me, either way, shrinking or growing. But you definitely, when you have something that's, 36 inches is going to make a difference as far as the shrinking. But then again, the longer you go, so if you take something like this and you stretch it out for several more feet, so there's 8 feet, that's 96. This is going to grow a lot more. It will be the same this way because it's literally still 8.5. So the amount of molecules going, north and south here will be the same. But you have that many more molecules wanting to say, excuse me, to its neighbor, and then passing that down. So this is going to grow more than this. So it's more important to have that. Yeah, or it's most important to have that. So what you need is 3 things plus the size, but you need to have the temperature at the material that, the material is when you actually cut it, which can be any temperature. In the summer, it could be 100 degrees in the router shop, in the router department. And that acrylic sitting around could be 90 degrees just sitting there. So you need to plug that in. So we'll get rid of that example there. And then, so we have this, right? 8.5 by 36. So let's say the cut temperature, we're going to cut these, well, I'm gambling. It's not that important, but let's just say it's going to be 85 degrees in the route shop. And the acrylic is 85. It's just been sitting there. It's not in the sun. That's the other thing. If it's sitting in the sun, you got to take that into account. So it's always good, Jose, hopefully you let that stuff cool a little bit before you throw it on. If you take piping hot acrylic that's sitting in the sun that's 120 degrees and you throw it on the table and then you route it, it's going to be smaller after you route it. And so, yeah, lesson learned. So at this temperature, I'm going to go ahead and take this and I'm going to duplicate it. Come on. And I'm going to hit X, which is going to fill this in. And then we are using, there's Tough-Ac, polycarbonate, but Plaskolite. So I went to their PDF and I got this off of their thing. And I'm going to hit compute. And so if it's 85 degrees and the final temperature, now I have 160. I went ahead and put that because that black Corian, I had a surface temperature gun at about 155 in the summer. It was pretty bad. So that's kind of worst case. Let's just say 120 ambient temperature. Maybe 130 with the direct sunlight. So let's go ahead and hit compute again. So it's not so bad, but you can see with the heat, we have over a 1/16 inch growth from the heat that way. So what I'm going to do is I'm going to go ahead and duplicate this and I'm going to hit red for hot. And then I'm going to hit this right here. That adds it to both sides. And so now this will be the grown size at 130 if I leave it at 85. So I'm going to go ahead and do this again, except we're going to do it with cold. So if you cut it at 85, but let's say it's a cold snap and it gets to be 30 degrees, super cold, I'm going to hit compute and it's going to go the other way. And you can see where it actually going from 85 degrees all the way down to 30, we're shaving off over a 1/16. So I'm going to go ahead and shrink it. Then I'm going to go ahead and do, or no, that wasn't shrink, the other way, the yellow one. There you go. So I'm going to shrink that. Then I'm going to hit blue for cold. Okay. So now I'm going to go ahead and bring these together. And you can see that's the difference. So at 85 degrees on a nice spring day, we cut it. And it's 8.5 by 36. In the summertime, it's going to be 36 and a 1/16. It's going to want to grow. But by the time it gets to winter, it could shrink on a very cold snap to 35.92. So that's how much expansion and thermal moving around this face is going to do. Now let's just do the Y. I'm going to show you why it's not really that much. See, it's 0.01, but we want to keep that in mind. So I'm going to shrink that. And then we're going to go, what was the final temperature? 130, right? For the hot boy. And then we're going to grow that one. There we go. So it does grow a little bit. Again, that's why I want to leave that this extra here, because it is going to probably fill that in the summer, right? Because that's going to want to grow that much more in the summer. But that's how much the faces are going to move around in respect to when we actually cut them out if it's 85 degrees. Now, all of this changes if it's a cold winter day. Let's just show what that would be. So if this is the size, 8.5 by 36, but it's 55 degrees, and the acrylic's been sitting out all night, and then you get cracking at like 6 in the morning, you can see the difference. I'm going to grab the Y here, or the X, I mean. So you got 36. If it's 55 degrees when you cut this thing, and like 6 months later in the summer, yeah, you're almost a whole eighth. So I'm going to go ahead and just do another one here, and then we're going to grow it, and that's going to be our red. Okay. And then it makes sense that if you're already cutting it in the wintertime, and then you've got 30, I'm going to shrink it. So if you've cut it in the wintertime and it's 55 degrees, that's your 8.5 by 36. It doesn't have much more to shrink because from 55 to 30 degrees is not a lot. The problem with routing this stuff in the summertime or in the winter, and then you have 130 degree summer, is that's how much you need to allow for expansion. So right now is kind of a good time to be routing this. Hopefully 85, 90 is closer to our hotter days, but I would really need to make room at this point. If it's going to be 55 degrees when we cut it, I need to make sure I leave a lot of room for expansion, because there's a lot of room to go from 55 degrees to 130. So anyway, that's what we need to figure out right now. That's what we're doing. So yeah, so I already kind of figured it out, but I'm going to go ahead and use this I'm going to use this actually. I'm going to use the longer one. So since we already kind of dorked around, I could have just wrote it down, but I wanted to show you what was up. So let's just say 85. I'm going to do a final temp of worst case. Let's just say 140 degrees. It's blistering. It's the afternoon sun beating on it directly from the west, just pounding on it. So let's see what we get for Plaskolite. And that's going to be 0.079. Okay. So I want to go ahead and grow this by that. So I'm going to duplicate it, and I'm going to do, let's do purple. Well, let's do orange for hot, because I already have red. So it's unfortunate, but I'm going to grow it. So that's my hot there. And then let's do the cold. So we're going to cut it at 85, and let's just say a cold snap of 30. We're going to compute. And it's the same because it's right in the middle. Yeah, 85 to 130 to 30. Yeah, exactly. That's it. So I'm going to go ahead and shrink this by that much. There we go. So it just happens to be actually a pretty good number to shrink and do that by. So this would be the amount of room I need to shrink, and then this would be also the amount of room I need to grow. So I need to actually use this as the max shrink, and then this would be the max grow. But you can see where this box is already like it will outgrow this box by that much. So I need to either make the box grow, or what I'm thinking is I'm going to shave this to where this is the actual size, right? That way it will grow. So I'm going to make this one the actual size, right? And then I'm going to get rid of this. So this will be, actually, you know what? This will be, I'm just going to move everything over. So there you go. So this will be the size that it will be at its maximum heat. And I'm going to go ahead and make this the actual size. And then the actual shrink size, which we could compute again. There you go. So I moved everything over. So theoretically, to make sure that nothing wants to pop out, this needs to be the 85 degree route temperature from there to there. Okay. So that is the amount of flange. So again, I'm not going to worry about this because that's going to grow just right, because I'm going to leave this much space in between. But for this is how much offset that I'm going to go ahead and make this flange that much longer. And then that's going to be that much float between where the screws are actually going to attach, which is right there. And then this will be how much it can grow, and then this will be how much it'll shrink to here. And then the whole other point of that is to make sure that we don't really want to tighten the screws down that much, because as this shrinks, it's going to want to pull away. And if we tighten this completely, so the whole idea is you want to make sure that these screws are just sort of in there to keep it from wanting to fall out completely. But this is kind of on install, that you don't frap that down completely tight, that this thing needs to be able to, you know, heave and move with the seasons. That means that the screws have to kind of go with it. So anyway, so that helps me right there. And I think that is enough to nail it down. So now I'm going to get my side nugget view. And so I think this will be our aluminum box, our 063 box, right? So that's going to be that corner there. Actually, you know what? We're going to make this guy be the loser. See the last videos. And that guy's going to be the winner. Because that way, when you look at it from the side, there's no seam. And the seam will be on the top, and the seam will be on the bottom, tucked away. And then the way I'm going to do this, actually, Ashley, whoever Ashley is I'm going to go ahead and make these a 2-piece box that's going to come off the router in 2 pieces. We're going to bend it up, and then we're just going to rivet it together. And we're going to have a rectangle box out of 2 pieces of 063 aluminum. And then I am going to, like I said, I'm going to offset my flange that much in order to be safe for the coefficient of thermal expansion. All right, so I hope that was confusing. I hope to hear from you with questions going, I have no idea what you just said. Oh, by the way, I was also thinking it'd be kind of cool is I'm going to use this profile and I'm going to 3D print a drill template. Since we can't CNC route sideways, we're going to go ahead and route these out. But then I'm thinking I can go ahead and make a little template with some drill guides, and then the guys can use that to line this up and drill 2 holes that will perfectly match the holes that are in the side of the box, right? And that way the screws go in there. And I think that'll be money sauce. So anyway, so that's it. I'm going to keep going on this. Hopefully, hopefully be able to show you more strategies.